which will also enable you to technically understand more about the world of radios, antennas, radio propagation, and so on. My name is Jegan Mani. My call sign is Victor Uniform number 3, Juliet Yankee Uniform, or VU3JYU. That's my Indian call sign. And my American call sign is KN6GRH. Okay, so can we get started? So we'll start from the basic understanding of saying uh, we'll see what ham radio or amateur radio stands for. We'll also see from the history of amateur radio how the hobby evolved, how the field of radio communication evolved, and we'll also see what is the relevance of ham radio in today's connected world, where not just you are connected to the rest of the world through internet, even your microwave is connected, even your refrigerator is connected. Yeah. Okay. Can you see? Is that okay? Okay. Yeah. So I was saying, we'll also see what is the relevance of ham radio in today's world of everything being connected to internet, right? So it's no longer just uh, a individual using internet to send information across the world. It's everything being connected. And in such a scenario, why is even this hobby relevant anymore, right? And we'll also start answering a few questions in terms of how can one become a ham, or how do you get a license for amateur radio, and what would you gain by becoming a amateur radio operator. So what should your shack contain, and how can you help others by becoming a ham. And quickly, if time permits, we'll also do a quick demo. In the demo, I'll show you shack have been reaching all around the world, and I will also show you probably a quick chat based on who is available online. We'll chat and see how a typical QSO or a conversation over the radio happens. And then I will open the floor for question and answers. All this in about 40-45 minutes is what we are planning to do. Okay, let's get started. So ham radio or amateur radio is a hobby, and by law it is completely non-commercial activity. So whatever a ham radio operator does shouldn't be connected to commercial activities by any means. You can use the radio, you can use the communication equipment to transmit, and always remember that the channel is going to be open. So there cannot be any conversation in the channel which would offend anyone's belief, and there should not be any political motive to it, there should not be any commercial value to it, and you cannot be transmitting in behalf of someone else, except when there is a life in danger. The rest of the times, it is only you who is transmitting to talk to someone else, and it has to be in a polite way. It has to be without offending anyone. That's the overall rule. And you'll also find that ham radio operators are typically among the first responders. So a ham would respond to any emergency, would operate and maintain a communication network till the point where the communication network is recovered and fully operational to the final state, right? So it could be in times of floods, it could be in times of landslides, any calamities, any emergency situation, there would be a ham or a couple of hams who are operating in that state. Even in the recent times, we have been part of the COVID-19 emergency war room setup, wherein we were coordinating for distribution of relief material, making sure that migrant people are able to board the right trains and buses and so on. And we had a station within Karnataka government's CM's war room. So we were operating 24/7 from that station. Okay, that's about ham radio. So what is the history of ham radio? So there is no clear start date for when this hobby started, but what we know is from the very early stages of radio communication, from that point where it was possible for people to communicate or transmit information through a radio setup, there have also been people who have been parallelly trying to do this. So once we had radio telegraphy, there were also parallel networks of radio telegraphy. But it is not till the point about early 1900s that it was formally recognized and there were rules to regulate who can operate and how they should operate. It's often referred to as the first social network because you would connect with someone, make friends in the way. And the early systems were also based on the Hertzian way of radio, which means there would typically be a spark gap. And because of the spark gap, you would eventually be transmitting or emitting radio waves in not just the band of your choice, but also in a very wide band, which means that it would interfere and disrupt commercial transmissions. It would also interfere and disrupt military communication, right? So it is in 1920s when the US Congress passed an act. It's called the Radio Act. And that is when ham radio operators or amateur radio as a hobby and as a formal way was recognized. And what the Act also made sure was to say that the ham radio operators cannot transmit in any frequency of their choice, but only in a restricted set of frequencies. So a limited set of the spectrum was allocated to the ham operations, and it was expected that only within that limited spectrum that the ham radio network would operate. Okay. So it all started as a simple Morse code, but eventually, when the radio systems and the electronics in general got more advanced, what many were able to do was to take military surplus radios, like what an army would use and then discard it. They would retrieve that radio and then they would modify it to make sure that it works within the ham band. And these radios were then used to transmit in AM and SSP, that is amplitude modulation, and as a part of amplitude modulation, single sideband was also part of the transmission that or modulation techniques that were used. The downside of using an AM is that AM uses a lot of carrier, or it is modulated over the carrier, which means that a lot of energy that is transmitted is actually wasted only because of the carrier. In order to make sure that the systems don't get heated so far, then they had to remove the carrier. So it is called SSP-SE, which is single sideband, wherein you use only one small portion of the sideband so that a lot of others can use the same frequency. And it was also made sure that the carrier was suppressed. So you don't transmit the carrier, which meant that you don't need a lot of power to be transmitted. And as the electronics kept advancing, you currently are in a state where your transmitters are as tiny as your mobile phones, in many cases even tinier than a mobile phone, and they can transmit anywhere up to 5 to 10 watts in most cases, and they operate with VHF or UHF frequencies. And these transmitters typically operate with an FM modulation. Okay. And now we also have digital communication where you communicate through a satellite. And most of these digital communications, they either use FSK or QPSK kind of digital modulation techniques. So starting all the way from Morse code till FSK and QPSK, not much has changed. The bands are still the same. The motive is still the same, to make friends all over, to have an interesting hobby, to advance the art and science of radios and antennas and propagation. But what has changed is how people use this for communication. Okay, and what modes of communication can we do? What has also changed is in the earlier state, because it was only simple Morse code, it was very simple information that were exchanged. But in today's case, you can actually send an email without having the need for internet. You could send pictures and videos without the need for an internet or any other network, right? We'll see how all that is done. Okay. So this is the band plan. A band plan is essentially saying which segments of the frequency spectrum are allocated for a amateur radio operation. So you don't have to go through this in detail, but just to remember that as a ham radio operator, one is expected to operate only within these specific frequencies. At no point shall an ham radio operator basically transmit any information outside this band of information, outside this band, right? And at each of these bands, there's also a restricted amount of energy that one can use to transmit. So the band actually starts all the way in the kilohertz range, which is actually in medium wave range, from 135 kilohertz all the way till 1.2 gigahertz, right? So that's a huge amount of frequencies that the hams are allowed to operate, but it's also limited in terms of bandwidth. Okay, we'll cover this in more detail in the later slides, but just to show you how many bands we can operate, how many different forms of modulation one can do, and how many different setups or antennas that one would need in order to operate on all these bands is going to be very interesting. Okay, so what is the relevance of such a technology? What is the relevance of wireless in today's technology where everything is connected or interconnected? The fundamental problem with today's technology or today's mobile communication is that everything is connected. So a mobile phone, irrespective of how expensive or how cheap that mobile phone is, becomes useless the moment the cell phone tower is down, right? As long as you have a base station working, as long as you have the central cell tower working, then your mobile phones can communicate. At the point where the tower fails, your mobile phones are useless. So it could be because of power failure, it could be because of internet connection issues, it could be because of a whole lot of other things. But it is not a solution that can be relied on when you have an emergency situation. On the other hand, a ham radio operation doesn't depend on any of these networks. At any point, a trained ham radio operator should be able to set up a network, should be able to bring up a station in a maximum of 1 or 1.5 hours to an operational state without having to depend on power, without having to depend on an already established network, without having to depend on already created aerials. A trained ham radio operator should be able to make a station operational within as much as within a span of say 1 hour, right? And the other biggest advantage is that the ham channels are open channels, which means that anyone monitoring that frequency will be able to take part in the conversation, will be able to contribute to what is being said in that conversation, and will also be able to take that information and communicate it to a larger group if required. So let's assume someone is in a remote area and all that they have is a single walkie-talkie, right? A simple walkie-talkie may put out a power of say 5 watts to 8 watts, and with 5 watts to 8 watts, typically you cover a range of say 50 to 100 kilometers. So if the propagation is right, everything is working fine, then probably you can reach other hams within the range of 50 to 100 kilometers. And if you want to communicate further, then you probably need something called as a repeater. Or if someone who is say at 30 kilometer range is able to receive your signal and pass it on to other hams, then You then establish a chain of communication, and that is how you manage in the times of disaster. You don't have to depend on an existing network to cover it. And hams can also use satellites. So you are not just limited to one terrestrial mode of communication. You can also use satellites to basically cover a larger area. So there are many low Earth orbit satellites, and there is one geostationary orbit satellite that is available for a ham to use, which covers almost like 3/4 of the world's footprint. Okay, so in the pictures, essentially you see a few people or a few hams coordinating relief activity during the times of Karnataka, Kerala floods. And in fact, one such activity was where it was managed along with the help of the postal department. So the hams were able to work in tandem with the postal department and made sure that enough money was released from an individual's account for them to sustain through the flood. Probably about 1,500 rupees, if I'm right, was released from their postal account. Now, the situation to remember is that the post office was completely submerged in water. There was no possibility of the post office operating their computers to see if the account really had so much funds. So the way they managed the situation was to basically communicate this over the ham network. And there was a similar ham operator who would be sitting in a post office which had internet connection to basically check whether there were sufficient funds. And if they had sufficient fund, then they would release that money based on the confirmation that they received. And then they would also make a similar adjustment to the account later on. And the lower section of the screen, you can also see the recent activity, basically activity of Bangalore hams from the Karnataka CM's COVID-19 war room, where we were able to coordinate relief activity. We were able to coordinate food distribution, medicine distribution, and other things based on people on the field. So we would operate from the control tower, the control room, and there were a lot of people who were operating on the field. And we were able to establish the station, get everything up and running in a span of about 1.5 hours. Okay? So that's how this ancient technology or the old technology and hobby is still active and very much relevant in today's world. So as I said earlier, it is also possible to exchange emails. So you may ask, why email? An email might be required if you want to send information over a longer distance. Let's say you want to send information and the channel is not very clear. But because this is all digital information, you don't actually have to make sure that the receiver really understands that information. And the other advantage is you can even send attachments. So if there is a need, you can also send a picture along with your email. So that's one way of doing it. And there are also other means to do, like track in real time. There's something called APRS, with which a ham radio operator can basically report position. So for example, a set of operators go on hiking or trekking or skiing. So it is important to see what is their position in real time. So APRS would basically transmit a packet of information in a periodic manner to let their positions be known to other ham radio operators in the vicinity. And then you can also have a mesh network created. Thereby you spread the information till the point where it reaches the final destination. Many hams are also interested in getting real-time weather information, weather feeds from satellites. So whenever there is a satellite pass, like a NOAA satellite or a weather satellite that passes over it, a ham radio operator would receive the satellite feed and immediately see what is the forecast like for the next probably 6 hours, 12 hours, whatever. Right? And as I said, because you can create a really large mesh network, it is possible for hams to relay information or traffic, as it is called in the ham lingo, across a vast distance without actually having to wait for any of the existing infrastructure. You can just pass this information along. So the first picture, the top picture that you see is software through which you can send emails. Looks very much like any other email client, like Outlook or any other email client. And it could be text, and there can be attachments to those emails too. The lower section of the picture essentially is a software, a snapshot of the software that is used to send SSTV. SSTV is slow scan TV. So you can send pictures or even slow images or slow videos through the software, through the radio. All that without the need for any other sophisticated equipment. Okay. So who can become a ham? The simple rule is if you're above 13 years of age, then you're cleared about half the requirement. The other half is to make sure that you clear a few easy exams. They're not really hard. The whole intent is to make sure that a ham radio operator is able to understand the theory of radio operations, understand the theory of electronics, so that if there be a need, a ham radio operator would be able to service their own equipment and build new equipments and make sure that it's a technical hobby. Right? And there's also part of the exam will also test you on your familiarity with radio regulations. So that's for the basic operations. So if you want to clear the advanced stage, then you would also need to clear Morse code. If you are not comfortable with Morse code, that's fine. You don't have to know Morse code to start with. The only drawback without knowing Morse code is you will not be given an advanced level clearance. Without the advanced level clearance, the amount of output power that you put out would be limited. So for a restricted grade like me with a VU3 call, I am eligible to transmit only about 100 watts in HF frequencies and about 10 watts in VHF frequencies. And if you have an advanced clearance, so your call sign would become VU2 instead of VU3. And if you have advanced permits, then you can actually transmit about 400 watts in HF and about 25 watts in VHF. Other than that, there is no other limitations. Okay. So what would you gain by becoming a ham radio operator, right? Typical answer to this question is there's a lot that you would gain. There's a lot which are tangible and there's a lot which are not tangible. To start with, you will have a very deep understanding of radio topologies. You will be able to understand how the radio systems work. You will be able to understand the different transmitter schemes. You will be able to understand different receiver schemes. And you'll also be able to understand how the different topologies work. And you'll have a very detailed understanding of antennas. So there are many different types of antennas. There is no end to building an antenna. It's a very fascinating area. So you will start building a lot of antennas, and you will have a good understanding of how propagation works on a day-to-day basis. So with a lot of information available, you will be able to see with information like weather, with information like the solar index, you'll be able to say how far can your signals reach, right? And you will also have a good understanding of different power supplies. So you will be able to build new power supplies. You will be able to repair power supplies. Overall, one would become a good engineer and a good technician. All this without actually having to have an engineering degree or a technical degree. I know hams who are essentially farmers, school teachers, students in their high schools, but because they became ham, they have a keen interest in these areas, and they have been able to build their own radios, and they have been able to build their own antennas and so on. So you really don't need a technical degree to basically pursue such an hobby. So I say you become a better engineer and a technician. So I can tell you a story about myself. I hold a bachelor's degree in electronics and communication and a master's degree in automotive electronics. But it was not before I became a ham that I actually started understanding antennas and propagation in such details. The first thing that I did after becoming a ham was basically to see what kind of antenna would I need to reach a further station. So the answer was very easy. I needed a more directive antenna. So the next question was, how do I build a directive antenna? Well, there's a lot of literature available out to say that you need something like a Yagi structure. But how do you actually see what kind of structure, what kind of antenna would you actually need to reach a particular station, say 600 kilometers away or 500 kilometers away? So then you need to do something a bit more serious. So you need something to simulate. So I started doing simulations and optimizations basically to see if a particular structure or a particular antenna would suffice for my need. And what you see in the screen is essentially the simulations and optimization results for one such structure. So it is a Yagi-Uda antenna. So you would have seen the old television antennas, a very similar structure. But we had our own set of challenges to come up with this particular structure. For example, this particular antenna is about 20 feet above my terrace. So with such a big height, there's also wind factors that have to be considered. So I cannot put a long, say, 4 meter, 5 meter long antenna so that I have a long or a better directivity. At the same time, I needed a minimum of 8 dB, 9 dB gain. And the maximum that I could do is to basically put a 2 meter long antenna. And most of the Yagis are typically about 300 ohms impedance, or you can also make a few with about 75 ohms impedance. But most of the ham equipments operate at 50 ohm impedance. So you basically have to do some kind of simulation, some kind of analysis. Don't have access to such softwares to basically come up with the right design. There's a lot of information on how to build such antennas in internet, but being an engineer, I wanted to do things ground up. So this enabled me to think not just in terms of electronics or simulation, but more in terms of the overall picture, more in terms of what would be the mechanical stress at a given point, what would be the wind factor, what would be the impact of reducing size, or can I reuse some other materials to build such a structure, and so on. So I think it made me a better engineer, and I have heard similar comments from a lot of other people too. And the other interesting side effect, if you will, of this hobby is many of us become a DIY expert. Many of us start building our own tools, our own equipment. We become fabricators, we become tinkers in a lot of areas. So some of the things that you're seeing here are like dummy loads and a few other loading coils and antennas, which are all built by hams like me. Right? The first 3 pictures are essentially things that we built almost the very first year of becoming a ham. Right? And we also have a Bangalore ham who is basically soldering or building copper pipe-based antenna for a longer communication over VHF. The other antenna in the lowermost section of the screen that you see is essentially something that is built out of the scrape wood and metal that one had in his home. Right? But that's a very functional antenna. He is able to reach all the way from Ahmedabad to Pune with that antenna. Right? So it's not the question of what you need to build an antenna, it is the question of what kind of structure can you build and how much can you how much longer can your signals travel. And you become part of a very interesting group. You automatically become part of a group which is willing to help in times of need, be it flood, be it COVID, be it any emergency. There's at least a couple of hams who are ready to help and ready to be deployed at any point in time. You get exposure to motor sport. I never had experience of being in a motorsport area earlier, but after I became a ham, I was able to participate in motorsport. Not that I was driving a rally, but I was still communicating from remote areas in the rally, making sure that the drivers were safe and there was no obstacle on the tracks for other cars to pass through, making sure that the people who are driving or riding in the rally were safe at any point in time. And hams also have other ways of enjoying, right? For example, there is a sport within ham called fox hunt. It's not hunting in any means, but it is essentially looking for a hidden transmitter, like a treasure hunt, if you will, a more technical treasure hunt. So a transmitter or a radio transmitter is basically hidden at some point. And then people use all sorts of equipment to see from where they are getting that signal. And essentially they hunt for the hidden transmitter. And at a point where the transmitter is found, you basically win the race. So it's like a treasure hunt for the radio operators. And then there are a lot of other ways in which ham radio operators have fun, right? So there's something called Island on Air. For example, these people went to Dhanishkodi and they had a remote station operating from that island for about 3 days. And they made a huge amount of contacts from there. And there is also something called Summit on Air, or where we go to a remote hill station, set up stations from there, and then you talk to other hams. And these are all like different contests. So these are contests or events or sport, if you will, in the technical nature, that kind of make sure that the things that you learned are put to use, and you learn new skills every day. That's the whole point of being a ham. So I've spoken a lot about what hams do. So the next question is, let's assume you have cleared your exam, and what would you need in your shack? So shack is essentially like a small place from which you transmit. So that's your radio station. So no shack is built overnight, and it shouldn't be. It's not that you can't buy equipment. You can buy equipment. And if you buy the equipment all in one shot, trust me, you won't enjoy the hobby. You will very soon lose the interest in the hobby. So typical ham radio shack has to be built ground up. It has to be built over periods of time. And the rule of thumb in most cases, you start small. You start with the most simplest and the most economical transmitter you can find, and you start building on top of it. We started with a simple walkie-talkie. We started with this walkie-talkie, and today our shack looks like that. So we started with this simple walkie-talkie, and with this simple walkie-talkie and a good antenna, you can reach all the way from Bangalore to Aircard. Aircard, there is a repeater which would enable us to cover most of Tamil Nadu, portions of Andhra, and portions of Kerala. Of course, portions of Karnataka. So with this handy, which costed us about 4,000, 5,000 rupees, I was able to cover almost about 35, 40% of southern India, which is a big deal, right? And from there, we moved on to a VHF transceiver, a base station like transceiver, which meant it was more robust. And by the time we had also got a good antenna, we built a very good Yagi that I showed you some time back, and with which we were able to talk all the way till Kodaikanal, Coimbatore, and so on. So it further extended our range. My father, who is also a ham, his call is VU3JYT, once was able to make a contact all the way from Bangalore to Colombo. So the conditions were so nice that day that he had sufficient VHF tunneling that he was able to make a good contact with stations in Colombo. Now, if you look at it, which is like about 1,000 kilometers from here, so sitting in your shack, you're talking to someone about 1,000 kilometers away through VHF, which is a big deal, right? Then you would need a HF transceiver. So HF transceivers essentially open the whole world to you. VHF has a very limited range, but HF would basically open the whole world to you. So with a good antenna and a good radius, like a good HF set, and probably a matching tuner, you will be able to reach almost 3/4 of the world. And you would also need a good linear power supply. SMPS basically cause a lot of noise when you transmit. So SMPS is not a good choice for powering ham radios. You need a good linear power supply. And you also need some basic test equipment like a digital multimeter to basically measure or check if there is continuity, to see if there is the right voltage that's coming from your power supply, see how much is the current drawn, and so on. And then you would also need a basic set of tools to operate or set up your station. So that's all that you would need. But it's not that you need all these equipments to basically start or just to get on board. To basically get on board, you basically start with a VHF transceiver. In most cases, a hobby, a handheld radio or a walkie-talkie like what I showed you. Right. So what can you do with a VHF and UHF setup? VHF and UHF radios are going to operate only at line of sight operations. So basically, you have very limited range with VHF and UHF stations. So the other drawback with VHF is also that the VHF frequencies are also absorbed by the plants and trees around you. And in the urban setting, your buildings also observe VHF propagations or observes VHF, so the propagation may not be all that great if you have a low power transmitter. So to get over these issues, the idea is to place an antenna on top of your terrace if possible, or the highest point where you think you will have access to. Thereby, you will have a bigger coverage. All that matters in most cases for a ham communication is how good your antenna is. It doesn't really matter how much power you transmit in most cases. As long as your antenna is good, you will have a good reception and you will be able to transmit. So UHF and VHF, they also have repeaters operating in these. There's a lot of repeaters that are active, and these repeaters essentially let you communicate over longer distances. And repeaters also make sure that it is possible for you to do duplex. So it's not just simplex, wherein one frequency is used both for the transmit and the receive, but it's going to be duplex, which means you transmit in one frequency and you receive in the other frequency. And because most of these repeaters are located in hilltops, they really cover a large area, right? And with a simple handle radio like what I showed you, it is also possible to basically communicate through satellites. And because satellites are orbiting at a low Earth altitude, their footprints are really large. Like what I have shown in that picture, you can see that that's the footprint of a satellite AO91. And you can see that the satellite covers all the way from Myanmar all the way to Saudi Arabia, right? So any ham in that sphere would be able to communicate with any other ham within that sphere. But the drawback of such a satellite is that it's not geostationary. It's low Earth orbit, which means you'll maximum have a pass of about 2 to 3 minutes. So within those 3 minutes, you can have a contact with other hams in that region. There are also other satellites like the QO100, which is a geostationary satellite. But that particular satellite needs an uplink at about 2.4 gigahertz, and the downlink is at 10.1 gigahertz, if I'm right. So which means you need a different setup, and that's why I'm not talking about it today. So if we take a look at what HF can do, HF sets or high frequency sets basically operate within the band of 1.8 megahertz all the way till about 50 megahertz. And these radios basically operate based on something called as a skywave propagation. With skywave propagation, it's no longer just line of sight. You use ionosphere as your reflector. You use ionosphere as the mirror, if you will. So a signal that is put out from here, for example, from Bangalore, would basically hit the ionosphere and be reflected back to a different part of the Earth. It could be Japan, it could be Antarctica, it could be Australia, it could be anywhere, right? So because we use ionosphere as the reflection medium or the reflector, we cover a large area. And that's how the HF communication is feasible, or that's how larger distances are covered through HF communication. During the demo, I plan to show you one such coverage. In fact, I would show you how a signal, how the signals from my station has been received all around the world. Okay, and the HF band essentially also depends on the sun's heating of the ionosphere. It's because of the sun's heat that we have different layers in the ionosphere, and these different layers have different properties. So each ionosphere layer would reflect a particular set of frequencies. Based on which layer is active and based on which layer is reflecting the signal, you will have a different area where your signal would be received. And there are also different frequencies which can travel through different layers of ionosphere. So that's what is covered in this picture here. We start all the way from 160 meters, which is 1.8 megahertz. We go all the way till 10 meter band, which is about 10 meter band would be around 30 megahertz. Right? So that's the coverage of the HF band. And what this picture shows you are how these layers are active, and whether they are active during the day or whether they are during the night, whether they are active during summer or during winter. Based on these combinations, you can see which band to use so that you cover the maximum coverage. So you can see that most of the times the 40 meter band is active. The 20 meter band is active most of the time. So is 15 meters and 20 meters. So is 15 meters and 30 meters. So that basically shows the set of bands that most of the hams are active throughout the day. Okay. So with the same setup, you can also do digital communication. You don't need any particular fancy equipment to do it. You would basically need an extra computer to do this. And the software in the computer would basically modulate and demodulate audio signals that would eventually be transmitted through the radio. So most of the heavy lifting is done by the computer itself, and you don't need any other fancy equipment to basically do digital communication. And the picture in the lower section of the screen are different modulation schemes that are available in the digital area. And these are schemes that you can also use to basically understand the propagation effects. And these are also schemes that you can also use to basically communicate even when the band is really bad. By saying the band is bad, I mean, if the situation is that the ionosphere is not completely available, then you would hear a lot of static noise. But because these digital communication happen with much shorter bursts of high energy, they can go through even when the band is really bad. Okay, but audio communication may not be feasible. So these are the minimum set of equipments that you would need in your shack. You basically would need a digital multimeter. You would need an antenna analyzer, a power meter, and an SWR meter, right? Antenna analyzer is still not completely required equipment. It's a good to have. So is the power meter and SWR meter. But these are good to have equipments. Okay. So how can you help? Well, once you clear your exam and once you get your calls in, please join a local ham club. There are many ham clubs in most of the cities and metros. So once you join the club, there's a lot of experience that you would gain from the experienced hams. And over span of time, you will also be able to teach others. It could be other hams or other ham aspirants who are looking for some kind of a guidance. So you will be able to teach a lot of people. And also be ready to help in times of need. There is no mandate that you have to help, but it's a good thing. It's a more humanitarian thing to basically help when there is times of need. And you will be making friends without even realizing that you're actually making friends on the air. You'll be making good friends very soon. And make sure you enjoy the hobby, build more, do a lot of DIY stuff, learn more. So that's how you help the hobby. So we can do a quick demo. What I would like to show is something called as a PSK Reporter. So what you see on my screen now is essentially how my signals, it's a digital communication that has been going on the HF. It's happening on the 20-meter band, which is 14 megahertz. So that's my call sign that you can see. So the shack, so my shack is upstairs and the radio is currently transmitting in this particular frequency. And all that you see here are the number of stations that I've received. So you can see that there's a whole a huge number of stations that have received my signal. And you can also see that the pinkish color spectrum that you see here is essentially the coverage or the area where my signal has been received so far. So this would keep changing based on where the sun is active, where it is day, where it is night. It would keep changing. But quite a few interesting things that you can observe is there has been a contact with the station in Antarctica, right? Sitting in Bangalore, transmitting about 10 watts, I'm able to reach a station in Antarctica. Isn't that great? So you can see the distance chart. You can see that my signals have mostly been reached within, say, 4,000 to 7,000 kilometers, mostly within 5,500 kilometer mark. But there have also been stations which have been receiving very close to me. And there have also been stations which are as far as 15,000 kilometers from my station, who are still receiving my signal, right? And I can also show you the log. So if you look at the log, this is the last 24 hours when the station has been transmitting. And you can see how many stations we have covered so far, right? These are the number of stations, or these are the number of stations which have been receiving my signal and reporting these signals. Not necessarily I have had a contact with all of them, but they have been able to receive my call. Okay. So a quick look would tell me that my signals have been heard in 33 different countries in the last 24 hours. Isn't that great? I get goosebumps when I look at something like this. And when you see your distance chart and it tells you that your signal has been traveling as far as 15,000 kilometers, I feel absolutely fascinated by this. So that's about the HF and the digital piece. I'm going to make a call with my handle radio and see if someone is active. Okay, here we go. CQ, CQ, CQ. This VU3JYU calling CQ, CQ, CQ.
VU3 Juliet Yankee Uniform, this is VU3 Juliet Yankee Tango, VU3 JYT calling VU3 Juliet Yankee Uniform. How do you copy me, Jegan? QSL?
Roger that, View3JYT. This is View3JYU, currently in a live YouTube session. Good to hear you. You are coming in 5.9 on the direct. So if you can say a few words to the people who are listening, that would be great. Go ahead, View3JYT.
Roger, Jegan, VU3 Juliet Yankee Uniform, this is VU3 JYT returning. You are also full scale on the repeater, that is fine on the repeater. And W here around is 21 degree Charlie, very cool and pleasant here. Thank you, and I will be standing by. Go ahead, VU3 Juliet Yankee Uniform, VU3 JYT standing by.
QSL, thanks for the report. I will let you know after the video is done. Thank you, View3JYT, View3JYU. So that's a typical communication that you would do. It's called a QSO. It's essentially exchanging information in terms of the signal reports. That's the most important information for a ham. And then you also exchange information in terms of the weather condition in their station. In this case, it was my father who was in the vicinity, so it was not big. But if required, I can also make contacts through the repeater. So because these contacts are going to be through the repeater, then they are going to be covering a larger area, right? So that's a quick demo. And now I would basically say thank you, and I will open up the floor. So if there are any questions, I would like to answer those questions. Okay. Hope you enjoyed. I have a few questions now. Okay, I have a question from Akil Reddy from Hyderabad about becoming a ham and clearing the exam. So as I said, the exam is not hard, and if you have an electronics degree, even the requirement for clearing the exam or the electronics section of the exam is waived off. So you don't have to go through that piece of it. You just would need radio regulations. And to get started, you don't need Morse code. So it should be quite easy for clearing that exam. Okay. You can get in touch with NAIR, NAIR in Hyderabad. They would be able to help you. Okay, I'm sorry. The slide isn't moving. That's okay. I hope it is resolved. I have a question from Nagarajan from Tirunelveli asking if I can share the slides and the reference link. Sure, I would like to do that. I would get in touch with NPTEL and see how I can share this information to you. And I have a question from Kalyan Das from Calcutta. If I want to start my own amateur radio, then where to start? Well, the first thing would be to clear the exam. Uh, you can get in touch with the local ham radio clubs in Calcutta. They would give you uh, schedules of the exams. Then you should be able to clear that exam. Once you've cleared the exam and once you've got your call sign and the license, then, as I said, you can start with a simple handheld radio. I'm sure there is a repeater in Calcutta, so you can make more friends within this region. And then slowly you can move to HF, and um, I think that would be the way to go. So I don't see any other questions. I'm still keeping the form open. So if there are any questions, please post them so that I can answer them. Hello. Okay. So since there are no sessions, there are no questions, probably we can conclude the session. And hope you enjoyed the session today. So in the future, we'll talk more in detail about each of these sections that we covered today. Um, Thank you so much. And as we say in the ham radio lingo, 73s, have a good day. Thank you. Okay, a few contexts in terms of few stories in context with India. Well, in recent times, as I said, whenever there is a need, hams have come in and they have answered, or they have made sufficient communication setups in times of need. So every emergency, there has been at least a few hands who have helped in that state. There's a question from Vetri from Tirupur. Isn't the message encoded while transmitting? No, it's a strict no-no when you transmit in ham because the channel is a open channel. So none of your messages should be encoded when you transmit. That's one of the prerequisites. Okay, I can probably move it here. Then Sri Harsha from Raichur. I don't understand what NEP is, but I will get in touch with you so we can see how we can include it. And then there's a question from Chennai. How long does it take to get the license after giving the exam? Typically, it takes about 6 months uh, from the exam to getting your license and your call sign. Okay, any other questions? Okay, no other questions, and it's about time. So, thank you once again, 73s, and have a good day. You may close the session now. Thank you, Mahesh.